You didn't hear anything I said because but I'm not a person that can predict the future, but I just don't see how it would not go that direction soon. Okay, so what I did, I found an error somewhere here. So what? Okay, so I got to remember what it was I did. Oh boy, I may waste the whole period trying to fix this, but that's okay. We don't have anything better to do. First, let's see whether I'm right over here. Okay. Oh, and I don't have my picture up anymore. Let's see if I can get that picture up. Because it could be that I made a mistake on my picture. And I don't know whether I know how to get that. Okay. Okay. I don't know which one it was. Maybe it was that one. Now let's see if there's a way to load a. I am connected to the internet, it says. It's slow. Okay. That looks different than I was. That's a 3D calculator. That's okay. Was that? I don't know. Maybe it was that one. Oh, well, I don't know what it was. That doesn't look like it either. Okay, how do you load something? Open. Open a local file. Okay. Okay, it's got to be in. What? Where's my downloads? So I'm probably going to waste your time today. Okay, maybe that's it. Ah, okay. Okay, so my question is wait a minute. What is the L for? Point L. What is point L for? 16.2. Okay. L was on there. E to M. It says was 16. 2, 4, 6, 8, 12, 16. That's 16. Okay. So if it rotates about here and its velocity VC was 25, let's go back and see if VC was 25. Oh, wait a minute. Okay. So VC, okay, 96. Where did I find VC? Wait. I should have had VC. Okay. Okay, so let's just root. This is C to B. Is BC. Want to look for the equation DC and combine those together. Okay, that's it. DC. So what was omega CD finally? That's the question. What was omega CD? Okay. Now, wait a minute. Okay. Okay, so here's my here was my final velocity of velocity c. So the question is that the right thing compared to, it's not very easy to find your mistakes, what, more than a week later. So let's see what that comes up with. Just out of curiosity, that it looks like that might be it. That is really weird. All right, 25.55 is the magnitude. So the velocity c that I got from the instant center, wow, it is really slow, was exactly that. In the distance, CJ, no, CM was 13. And velocity c, omega CD, was the omega CD correct? 5.7. There's your 5.71. Omega CB. We checked that one out. Okay. So we got to check on that one. We got to check on that. I'm pretty sure that looks correct. So if we look at this as being this, the omega CE, that's the key. Oh, wait a minute. Okay. 25 omega CE. Wait a minute. I think okay, so let's see. 13.4. So what I'm doing here, taking the velocity of this point, the radius of this, to get the omega right there. And I think 25 divided by 13, that looks about right. It looks like about 25. It's almost 2. So I get omega CE of this. So that would be a minus 1.9 roughly. Do I get omega C? I don't think I got that. Yeah, see, I did not get that. So I'm a little bit more trusting of the instant center at this point. So I need to figure out what happened here in order to get there. So what I had done to get to this point, okay, so I got to here, and I think I was okay. So at this particular point, this is just moving a long link CE. We're just writing the equation along link CE. And let's see what I've done wrong here. Okay, so here's velocity of C, so the velocity of C relative to E plus velocity E. We're going to assume that it's sliding to the right. We have this from over here, and I am moderately okay with that. I think I checked that out, and I think that seems okay. Moving back and up, that means this velocity is moving back and up. So it's going along that way, which is perfectly perpendicular to that. I'm okay with that. What about my, okay, my omega CE is just simple, just write it in there. But then the question is, take a vector from E and draw to C. That would be a minus something, and I guess I can just 2, 4, 6, minus 6, and plus 4. So minus 6 plus 4. Now, okay, so I take the I, I'll take these and put here. Okay, for the J, I'll take these and put them there. And this is still moving to the right. So that times that times that. So it should be, oh, wait a minute. That's supposed to be a minus. Okay, so I'm going to circle the things that, okay, plus. There's a minus, a minus, a minus. Now, wait a minute. I'm getting this. Now, I'm a little concerned here. I think I may have played around with this a little bit. Let's look at the picture. And I guess what I'm going to do is steal the picture. Now I'm a little concerned. I'm going to use this little area to kind of monkey with this and see if I can figure this out. So I'm looking at this. I'm sitting on E, and it is rotating. Okay, this is an X, this is a Y, this is positive. So it's rotating like this. So it's got to be off, heading off this way, which means minus and minus. So I think I was supposed to have 2 minus signs here. Okay. If I end up with 2 minus signs, then we end up with that and that. I'll circle those. And I'll end up with this, but that doesn't solve the issue of the sign. That doesn't solve, I mean, the value. It's still something's wrong. Okay, so if this is 22, am I missing something? I got an X and I got that. So I'm copying that and copying that. And I get 22.857 over 4. That's still not the right number. So you know what I might do? This might be fun. Let's see what that number is. It's still going to be the same number, I think. Yeah, so it's the same number. It's just a positive. Does that make sense as far as the sign goes? No. Okay. It is back and up. That's correct. So there's something I'm doing wrong. I'm going to have to go find this myself. But I may actually do something crazy and give y'all this problem to work. Would y'all want to do that? No, I could give you a simpler one. A simpler one. Okay. I could do one without a link right here, and then these would be connected. So maybe I'll do it that way. I'll even draw it out for you and send it. Y'all have used this GeoGebra thing before? I haven't. I didn't use it till not too long ago because you could find all your distances on it. So what I could do is I'll do that. Uh-oh. Well, that messed it up. Maybe that's what happened. Maybe I got the... Here. Let me open it again. let's see. Okay, that was before I did the measurement. So you know what I could do? I could do this and make this link kind of set and take off this DC and give you all that problem to solve. Or I could find one in the homework thing. In the meantime, I'll go figure out the problem with this one because I've done something between those two, and it may take me a little bit of time to figure out what happened there. So that is, I'm trying to get to. Let me see what's in there. Okay, now let me see. Is that the right password? I have no idea. Apparently it was. I think I did that one time in this class where I just put an extra problem in there. And then this time I took it back out. So let me go see if I can find a good one. Okay. You know, one of the things I could do. Oh, these are all there. What's in 9? Oh, God. Oh, that's in the chapter 13. But I could add one there. I could put it in there. Let's see. Edit assignment. Let me just do that. And I'll go find. Okay, yeah, that's homework done. Looks like homework done. Item. Let's go find 16. Section. Oh, it may have to pop it. Okay. I'll find a good one there. And let's let it populate there. I don't really want to try to get rid of the featured item. An exhausted bicyclist. Okay. I guess that's I'm in that section. Okay, here we go. I'm just trying to read the things here and see if I can see. Okay, this one I can't really tell what that is, so I'm going to look at that. Yeah, that one looks okay. Is it that one? Did I just click? It was that one. You know what? I'll just add that one to this assignment like that. Because it has a velocity, it has acceleration. It's one single link. And how do I do that? Okay, let me think about it. What was it? It was that one, wasn't it? There. This looks like the same problem. No, it's not the same problem. But you know what? I think that one's already in there. Previous homework. Yeah, we'll just do that. How about that? An extra problem on it. So this will confuse people because it'll be 13-2. This will all be that 13, and then all of a sudden there's a 16 in there. Yeah, that's life. And if that's the case, then what I'll do is edit the date, and I'll make it available today. At midnight, it'll make it available. And we'll just go on. How about that? And I will make a video that fixes this. Don't expect it to be like very smooth, though. I don't make smooth videos anymore. I probably should, but. So when you get to acceleration in this thing, yeah, I'll have to go ahead and do that because we're just getting to the velocities, and so then I'll go into the acceleration. Okay, so for example, he's got this one velocity and acceleration here. And he's got the terms here, these terms. And so I'll need to complete that out so you can see all that in action. But then once you get past that, what you find out is there's nothing left in that chapter, in other words. You got instant center, then you got acceleration, a bunch of examples, problems. And I don't even want to touch on this one. It's an asterisk part, and it's talking about, if the fixture, whatever the thing is moving, and it's on an object that's moving itself. So in other words, it's related to, technically, all mechanical systems behave that way because the Earth is moving very slowly. So if something's accelerating back and towards me, it's going around in a circle anyway, which is partly why hurricanes develop the way they do. So if you think about it, if there's a particle in or let's say Chicago, because that's almost, and say Chicago and New Orleans. So just imagine that they're exactly north and south, but they're pretty close. So if you started in Chicago and you got on a train and you spent 24 hours getting to New Orleans, you think you're going straight south, but you've actually taken a helical thing because you actually went around the Earth. Now imagine if you were doing that and you were an air particle, and as you moved like south and as one moved north, what happens is this particle is actually going like this, and this one is going like that too. So what happens is this one being a little further up on the, closer to the center of rotation, has a different centrifugal value, which is how come as they come together, they start, as a low pressure region starts. Low pressure means all the air is coming towards it, but in fact, it going towards it and the Earth rotating means it starts in a circle. And that's what creates these things. That's what creates hurricanes. Tornadoes, that's a little bit different because it actually is a vortice that starts like that, but it doesn't have to do with the Earth rotating as much. You go down below the axis, it's that concept where, what do they say? When you flush a toilet in South America, it spins the other way. You flush it here, it spins this way. That is only occurring if the jets in the toilet come straight out. That's not always the case. But if you look at water draining down say a real quiet water thing draining, you'll see it eventually does that bit. It does it the different way in the south of the equator as it does the north. And it has to do with this, the relative accelerations. They seem like they're going one way, but actually the fact that they're on Earth, there's just a very slight amount creating that swirl. And you don't see it until the velocity becomes slow enough that acceleration affects it. So that's all that is. And I'm not even sure, it's called a Coriolis effect, and then that, I'm not even going to cover that, but I think I hope he uses that term, because that's what it actually is. Let's see. I haven't seen the word yet. So you get an extra term for a rotation. Okay, so the acceleration of B is acceleration A plus all this other stuff. So notice you get some of the stuff that looks similar, but some of it does not, because look right here. Well, I can't select that, but this VB relative to A, this is the one you regularly see. And this is the angular acceleration, angular velocity of the reference measured from, so it's like the Earth. it doesn't have to be the Earth, but if this is sitting on an object that's rotating, it has these terms here, these extra terms. Ah, there it is. So where that term is called the Coriolis acceleration. But we'll go ahead and skip out on that. Depending on the velocities of the other thing, it may have a larger effect. So with that, I'll go back and fix that problem and make an extra video. And now we'll go straight into 13, which actually goes rather quickly. Look at that. I ate some of that this morning. So really, this is ironic, but the acceleration is what you did in chapter 12 and some of 16. So now it's essentially now attaching statics to it. And the problems you start looking at, you start thinking, these are considerably easy compared to the previous. So I guess that's the end of that. I don't like the way this does. So then you got the equations of motion, which I thought I touched that, which maybe I didn't, which are nothing more than statics with the term on the right. And that's all it is. So you do the free body diagram, then you have acceleration. And so let me just throw down an example so you can kind of see what I'm talking about. It's incredibly easy per se. So if you had a block and somebody pushed it, let's say, we'll just make it simple right now. It's 100 kilograms and I push it with a force of 10 newtons and it's smooth. How does this work? Well, sum of the forces equal mass times acceleration. So you look at this thing, if it doesn't have any friction, it's unbalanced. So let's just do sum of the forces in the x direction. It's really unbalanced. On the left, you get, say this is positive. Then this you get 10. And normally you'd get something here. Well, that can't be, but it's 100 kilograms and it has an acceleration to the right. So now you know it's just accelerating at 0.1. So essentially all you're doing in this, through most of these problems, this is going to be constant. And so then you figure out what your forces are being put on stuff. And then you're basically just can convert this to this as a ratio. And that's all there is to it. There's nothing more complicated than that. So what you're going to find is you're going to find the problems like chapter 12 is a lot of junk and its complication level is maybe 8. Chapter 16, I'd say 10. 13, maybe around 5 or so, 4 to 5. And then 14, 10 stopped working. That's weird. Well, that is weird. Let's see if we can make it work. Uh-oh. Technology issues. Oh, now it's working again. So it's chapter 14 and then 15. One deals with energy. You'll find this complication. If this is 4 and 5, this is round 3. And I kind of rate this round 3, but some people may actually think it's more like 4. So the hardest part is what we're doing right now. From here on out, things get a little easier. So I have sufficiently wasted your time, and I didn't solve that problem and fix it, but I'll fix it. Maybe I got some other stuff to do this evening, but maybe I can fix it tomorrow sometime and just shoot out another video. Yeah.
It's all good.
We'll just call it good if you're fine.